So now it's time to run the numbers. So we figured out the torque of the load was 10.4 inch-pounds. Well, that's only part of the story. So here we go. We want to figure out the torque on this side of the pivot point. That's the torque of the load and the boom that wants to pivot, rotate the whole crane clockwise. And on the other side is the torque of the crane body wants to go counterclockwise. So the torque of the load we figured out was 10.4 inch-pounds. Remember, torque is weight times distance. Well, we know the distance was 14 because I measured it with my tape measure. But tape measure, that'll only get you so far. A better way to do it is with trig. Now don't run away, trig's not that hard. Triangle only has 3 sides and 3 angles, so there's only so many ways you can juggle the numbers. And I've taught this stuff to 5th graders, so how hard could it be? Alright, so a cosine is the ratio of the adjacent side over the hypotenuse. So the adjacent side, adjacent means next to, so this angle is this side. Now that side is also adjacent, but it's the hypotenuse, so that's what it is. So the ratio of this side to that, x, that's the dimension we want, over 28, that's the length of the boom. And the cosine of 60 is 0.5. So every angle has a different value of cosine. And how did I figure out 0.5? I looked it up in my handy dandy cosine table. So x over 28 is 0.5. A little cross multiplying, and x is 14 inches, which is what we knew. Okay, now we need to get the torque of the boom. The boom weighs 1 pound, and don't forget to find the measurement, the distance, we measure from the center of gravity of the boom, which is pretty much down the middle. So now we're measuring, so the hypotenuse on this smaller triangle, hypotenuse is 14 inches, and x here is the other smaller x is what we want. Over here, 60 degrees still, so it's 0.5. Cross multiply, x equals 7 inches. So torque of the boom, weight times distance. 1 pound times 7 inches, 7 inch-pounds. We add the torque of the load and the boom, 17.4 inch-pounds is what we get. Now what about the other side of the pivot point? The torque of the crane. Well, there's the weight of the crane, 1.8 pounds, and the distance from the pivot point to the center of gravity of the crane is 12 inches. Multiply, 21.6. This is greater than that, so the torque that wants to rotate it this way or keep it on the ground is greater than the torque that wants to tip it over. Well, we knew that it wasn't going to tip over. Now, we go to 45 degrees. Everything on this side, the torque of the crane hasn't changed, 21.6 inch-pounds. Well, we lowered the angle of the boom, so now it's 45 degrees, so this dimension is bigger. So, back to cosine. Here's our new triangle. The boom is still 28 inches long. This is the dimension we want, this large x. So cosine is adjacent over hypotenuse, x over 28. But the cosine is 45, and the value of the cosine is not 0.5, it's 0.707. Here we go. Cross multiply, 19.8 inches. That's this distance. Now we've got to find the torque of the boom, we've got to find this distance. Don't forget, we measure from the center of gravity, which on the boom goes through the middle of the boom. Here's the boom. So now we've got, again, 14 inches, and this is the dimension we want. Pretty straightforward. Now we've got 9.9 inches for this distance. So, the torque of the load, weight times distance. The weight, 0.75 pounds for the C-clamp. And we got the distance. Multiply the two, that's what you get. Torque of the boom was 1 pound. That's the distance, 9.9 inches. So we get 9.9 inch-pounds. Add these two together, 24.75 inch-pounds of torque. This is greater than this, so it tips over. Now there's plenty more videos and formulas and exercises on my two websites. PortlandJib.com. Jib is another word for the boom. And hammerhead cranes are the cranes you see around Portland. You call them tower cranes, but the official name is hammerhead.